Hi, my name is Jakub. I'm from H2O.ai. Anybody heard of this company before? Perfect. So I'll be talking about our integration of H2O and Spark. Let me start with who we are. It's actually just me here, but I always mention two people because it's kind of important. I'm Jakub or Kuba. I'm a software engineer at H2O.ai. I'm from Czech Republic, and I work on Spark Motor mainly these days. And there is also Michal. He's currently VP of Engineering at H2O.ai. And why I mention him is because he's the creator of Spark Motor. He doesn't work on this project much anymore, but he's the mind behind this project. So what I'm going to talk about is how in H2O we try to handle the machine learning lifecycle, because it's not just about training the model. It's about also the monitoring the model in production. It's also about the artifacts we use for the productionizing of the models, which tools we use, and so on. So before I start talking in more details about H2O and Apache Spark, I will just quickly introduce the abstract lifecycle which we need to handle in our machine learning task every day. So basically first we have some data in data lakes and we need to process the data. We need to load the data first and do some feature engineering on data cleansing. So the first box, we can think of it that we will take some data from the multiple data sources and we will join the data, do some basic data cleansing. Then if we want to train some models, we might do some feature engineering. We might do it manually, or we might use some tools, which I'm also going to show later, which can do that for us. So we do some feature engineering, and after that, we need to train the algorithm. It can be simple process, which will just transform the data. It can be iterative process, stack ensembles, and an AutoML task, which will basically find the best model within the given constraints for you. Basically anything what can build a model for you. But this is not the end. You just get yourself the model, which is actually the easy part these days. We have lots of tools we can use, and getting the model is kind of easy. The interesting bit starts with deploying the model. So what we need to do, we need to also apply, we need to take some simple data. It can be coming from your web page where user clicks on something. You get some sample data you need to run predictions on. You need to run the featureization on those data as well. You need to clean the data as well. And then you can run the predictions on the model artifact you just created. So this is the whole life cycle which we need to tackle without any tools mentioned so far. And I'm going to mention these implementations on two implementations. The first one is using Spark and H2O, which is our integration, which we call it Spark Motor. And basically, H2O is also our product. It's open source. It's a machine learning platform. It's cluster-based. And you can run any kind of algorithm you want, such as GBM, deep learning, all the standard algorithms. And in this tool, we try to integrate H2O with Apache Spark, so Spark people can actually use it nicely without worrying how H2O works internally. They can just use the APIs familiar to Spark users. The second implementation will use driverless AI, again in Spark remote environment, but I will get to that later. In both implementations, we will deploy the pipeline in form of Spark pipeline, and we use the different two artifacts for the model. In the first implementation, H2O Mojo. In the second variant, H2O driverless AI Mojo. What is that? I will get to that later as well. So the first implementation is H2O and Spark Motor. What is it? So I already introduced H2O a little bit. It's actually for special presentation to introduce H2O properly. So just in two sentences, it's machine learning platform. It's cluster based. It was written from scratch by our engineers, so you can run. For example, GBM is completely parallelized. We train different trees in different machines, so we get to your model as fast as possible, and we try to be pretty accurate as well. It's all distributed, and it's mainly for machine learning experts. Don't get me wrong, even people who are starting with H2O can use this H2O free. But sometimes you need to tune H2O a little bit more to get the perfect results. We have all the tuning you can. There is like 50 arguments you can set up for GBM, for example. So if you want to get best model, you need to know what you're doing. You need to have some data scientists which can do the best tuning for you. Of course, it will select some nice default, it will work, but you might not get the best model. So there is some expertise needed in this case. And Sparkling Water just integrates this ecosystem, this H2O and Spark ecosystem. Is anybody here using Spark? Perfect. That's for people who don't use Spark. Spark is basically a platform which is used for processing data in parallel, distributed platform for processing your data. So we use Sparkling Water to connect these two applications. And how this original, the abstract slide looks like in this example implementation, the first part is done in Spark. So we use Spark to load the data, to do the feature engineering in Spark, and then we switch to H2O. All is wrapped inside one application, which is called Sparkling Water. In H2O, we do the model training. We just need to, it's a technical detail, we just need to switch the data format when we go from Spark to H2O. But we have a helper methods for that. And when we go to productionization, we use just Spark pipeline. We don't have to have H2O runtime ready. We don't have to have H2O cluster available at this point, which kind of helps because you want to have your production pipeline kind of easy as possible. And introduce another cluster solution in a productionized pipeline can slow things down. So this is pure Sparkland. And we use Spark pipelines, which is a nice concept. You can write several steps into one artifact. Let's say you load the data, you apply a few transformations, and you train the model. And you can specify all this in one single pipeline, which is one artifact which you can share amongst your data scientists. So it's not scattered around. And this pipeline contains inside the H2O module model, which is the artifact which stores information about the trained model from H2O. So this was kind of abstract. Let me just show you a quick 2-minute demo how this will look in a practice. Can you see it? Should I make it bigger at the end? Just raise your hand if you can see it. I'll make it bigger. Is it better? Perfect. So this will be a really quick demo. I'm not going to be running it. I'll just go through it. This is a simple demo where we take some data and we will create some Spark pipeline. The data are simple. We have another tool called driverless AI. And this data contains information about how long the driverless AI took to train the model based on specific configuration. So let's say if you have had your data of 1 million of rows, it had 10 features, it was Windows or Linux where you train the data, so we have these columns. And we try to predict how long our internal tool took to train the model. But the data is not important here. So I'm gonna just load Spark. Here I'm just gonna do some technical details. I'm gonna import PySparkling, which is our Python wrapper for Sparkling Water. I'm gonna make sure that H2O is running inside of that Spark cluster, so I can use H2O models inside of this Spark cluster. This is just some details about the cluster. I'm using one node. I'm running locally. You can also go to our user interface, which is nice that you don't have to write any code. You can just click, train your model, run your predictions in the flow. But the important part is that is the Spark pipeline, how we define it. So the box 24 specify the first pipeline stage. This is called SQL transformer stage, and what it actually does, it will select all the rows where number of rows in the training data set was higher than 100. We are not interested in small runs of that driverless AI tool I mentioned a while ago. So this is just simple SQL transformer. The second transformer is provided by H2O. The API is really very similar to the Spark one, and what it does, it will actually run AutoML inside of this pipeline. So I don't need to actually specify much. I just say another pipeline stage is H2O AutoML. I'm going to give it 60 seconds. It won't do any extraordinary model in this 60 seconds, but it will do something. I'm gonna handle unknown categoricals as well. So if it sees unknown categorical in your prediction data, in your data for predictions, it won't die. It will just handle it as NA. I'm mentioning the prediction column T total. Here I'm just defining the whole pipeline. So I'm just mentioning the two pipeline stages in one single pipeline. Here I'm loading the data. PyData Miami is the simple data set which I mentioned before about the internal runs of the driverless AI. I need to convert the data to Spark frame because these pipelines are designed to work nicely with Apache Spark. So you can use Spark frames. You don't have to use H2O frames. But the thing I used H2O import file is because H2O spend a lot of time on improving the parsers, so we can infer the data types pretty nicely. So that's why I prefer to use H2O import file, because we know we can, even on small data sets, we can do a nice work inferring the schema and types. So here I converted the data to Spark frame, and I'm just gonna call fit method on the pipeline. What it actually does is that it will go through all the pipeline stages and it will apply them on this data. So it will first filter the rows which I don't want to have in the model, and then it will train the model. So it's actually nice, and you can store this pipeline on disk in your database. It works in the serialized pipeline works in R, Python, Scala, so it's language independent. And then I'm just saving the pipeline here. What you can also do on this model, you can call model.transform. And you can give it prediction data. I'm going to run it. And what this will actually does, it will again go through all these stages, but for the productionization. So you have the nice artifact, which is good for both model building and productionization the same model. Let me go back to slides. So this was a quick demo of how this works in Spark and Motor. And now I'm gonna show the very similar thing using H2O driverless AI and Spark and Motor. So all this before was open source. You can use H2O, Spark and Motor, Spark for free. We don't charge anybody for this. All the features available are there. You can just download it from GitHub or from our page. H2O driverless AI is a closed source product, but it's another alternative. I mentioned H2O AutoML before, and it's actually what it does. It tries to find the best model within the given constraints. H2O driverless AI is kind of another level. It brings AutoML to another level, and we try to do feature transformations also for you automatically, so you don't have to figure out which columns I need to split, what kind of transformation I need to do to get myself the best model. So this tool is good for beginners or for people who don't want to spend time on data science. They just want to get best model. They don't care how it's done. We of course provide all the tools like interpretability. It's all there. But if you don't want to spend time on tuning the models, taking care of features, you can use this tool. There is no expected knowledge from you, so it kind of replaces your data scientist. And there is automatic feature engineering. Why is this possible? We have lots of people from Kaggle in H2O who spend a lot of time on tuning the recipes for driverless AI. So we, for example, know if it's time series, we can apply specific transformations. We try to get the domain knowledge inside of driverless AI for the specific data sets. How the implementation looks like in this context. In this case, we use Spark just for the data cleansing and driverless AI for all feature engineering and model training. The productionization pipeline is very similar. We again use Spark to productionize this data using the Spark pipeline. What actually driverless AI does, it will create an artifact which is called H2O Mojo pipeline, which we can also use inside of Spark pipeline. So at the end, we have one single artifact, which is the same for previous solution and this solution, which we can deploy. Just a quick demo of how driverless AI looks like. I'm going to make it bigger as well. OK. So really super quick demo. I have this tool, which I have loaded the data set here. I can click on predict. I just need to select the target, the response column, and I have 3 knobs here, accuracy, time, and interpretability. I also enable GPUs by default, so it will use GPUs if you have them. And what actually does these knobs? Accuracy is how much you want your model to be accurate. If you decide to be really accurate, the model training will take more time. We need to decide what transformations we can use. We can use some specific transformations in this case. The same for time. If we give it more time, we can use more complex transformations, more iterations. When it comes to interpretability, if we want to have really high interpretability, we again can't use all the features, all the feature transformations, because it some feature transformations we use are not that nicely interpreted by humans. So for example, in banks or insurance companies, you need to really be able to explain somebody how your model reasoned, which path it chose. So we take care about that. And if I just launch the experiment, it will start working. This will take around 20 minutes, half an hour. So I'm going to wait for the result. But when it's finished, it will give us H2O module pipeline file, which we can use inside of that Spark pipeline. So this is just in case I wouldn't be able to run this driverless AI. This is just a sneak peek into what feature transformations we are actually doing inside of driverless AI. This is the full graph on I don't know how many features is there, maybe 100. But this is kind of something what we as human can process, these interactions. So that's why we have this tool for us, which can find all the interactions with these features and tries to give us the best model. Of course, it's I didn't mention, it's actually a closed source product, but for academia it's free. So if you are for academia, you can play it for free for eternity, and we have also free licenses. Before I spend time on this, I just want to show you how we can actually productionize it. So this will just start running. I will show the script afterwards. What I prepared here is a small script which takes these 2 Spark pipelines, the one for Sparkling Water and H2O, and the one for driverless AI and Sparkling Water, and it will start reading some S3 buckets where we put our data periodically from H2O, and it will run predictions on them in real time. It will take some time, like half a minute, to initialize, and then it will start running predictions in real time. I will show you the code in a bit, but all is in the repository, so it's easier to go to the repo and have a look on it. So I can see that it just works. You need to believe me on this. I don't have enough time to show you the full code base. But I just wrote a simple script which fetches the data from S3 bucket and runs the predictions using the Spark and driverless AI Spark and Water pipelines. I just want to show you the code behind it, because it's actually kind of easy. The first Spark pipeline using the H2O and Spark, I loaded as this. These are just technical details. I'm not going to spend time on this. So you use Spark method pipeline model, and you can load the Spark pipeline. In the second example, I just need to use specific helper method, which will turn the driverless AI module pipeline into Spark pipeline. So at this moment, I have the module 1 and module 2. Both these identifiers represents the Spark pipelines. different on the implementation, but from the API point of sense, it's the same. And to productionalize it, it's actually super simple. I just use Spark streaming datasets. I just specify the location of the data where we are putting them. I will specify the input data stream as the parameter to transform method, and I will start everything. I will start processing data by calling the start method on the output data stream. So I have just these 3 lines. It's duplicated because we have two pipelines. I just need to write these three lines of code to actually productionalize this pipeline, to start reading data from S3, HDFS, Azure, running partitions, and storing it somewhere. I'm just printing it on the console. Of course, just a side note, you can also productionalize H2O models outside of Spark environment. That might be helpful, for example, in some real-time use cases where Spark parallelization is just much overhead for processing one line of data on your input, but it's again for a different talk. This is just how easy you can do it in Spark environment. Okay, I still have 3 minutes, so that's perfect. So I mentioned the basic machine learning lifecycle, but it's not everything. You can see that this is the same slide as at the beginning, except these three another extra steps here. And I'm gonna go through them in a short time. So in order to have really full machine learning lifecycle, it's not just enough to put our model somewhere and run it. We should be able to auto-document the model, such as there is lots of companies which are trying to do that these days. For example, which configuration you use to run your model, which AUC the model, which AUC the model had. Basically, there is no need for us to do that manually. This should be done automatically. The results should be stored in some database, and we should be able to run some meta search over this data. The model management, again, when we create some nice model, we should store it somewhere automatically. If you have a big company, you have lots of data scientists training your different models, and there might be one super amazing model which somebody created, but 1 week after, you just don't know which configuration they used. So this will also help. And what we are also working on in H2O is the model monitoring. So when you have the model in production already, we would like to apply some monitoring steps, such as example is you have a simple model, binomial model, which are reading data from some web page. And the distribution might, for example, change. From at the beginning it was 50-50%, it might change to 80% to 20%. And this should trigger something, because either your model is wrong or the data changed significantly. So we need to handle the situation. So the monitoring can actually help us with that. It should be independent on the specific data. We should be able to apply it as another step. And the pipeline, the tool which is used for productionizing, should know about the monitoring as well. And with this implemented, it's actually kind of a lot of work. We should be able at the end to train the model, productionize it, store all the details to some databases for further research, and then if we find some changes in the incoming data, we can actually automatically retrain the model and start the loop again. This can be done all automatically in the future, but we are still not yet there. So it was kind of quick. I'm sorry that I was speaking that quick, but that's it. You can find lots of materials here, so you can just take a picture of it, or the link points to the same page. So there are links to H2O and Sparkling Water. And just to wrap it up, so Sparkling Water is a tool which combines the power of H2O and Spark, and it can be used to productionize H2O models from H2O free open source product, and also driverless AI tool. Thank you.
Thanks, Jakub. Any questions? Hi. How you compare the Spark ML with the H2O?
Yeah. So the question was how we compare SparkML to H2O algorithms. So that's a tricky question, and I'm gonna answer that in specific numbers. But we believe that we can do a bit better than SparkML. We think that it's a little bit behind. The answer I want to give is that we don't have our own benchmarks, but there is a guy called Szilard Pawka from Poland, and he does open source benchmarks of different tools such as SparkML, H2O. He's not affiliated to H2O at all. So if you want to have a look how we compare these data sets, I would suggest looking at the repository. Because if we would provide some benchmarks, it just doesn't make sense. Everybody would think that we just tune it to look good for H2O.
Another one here.
These are kind of general H2O questions, but I've been noticing H2O hasn't really gotten into deep learning very much. Is there a reason for that? And it'd be good to understand a little bit more about the license for driverless AI.
Mm-hmm. Okay, so there were two questions. First one was about deep learning in H2O, whether we still support it, whether or not. So we still have deep learning in H2O, the basic one, but we don't support complex neural networks in H2O. We had a project called Deepwater, which were integrating H2O with TensorFlow, MXNet, or Caffe platforms. But what we realized is that there is no point of competing with these tools. For example, TensorFlow is amazing, and it does a great job. And why should we spend time on doing something what somebody already working on and doing a great job? So if you want to use complex neural networks, I would say go to these tools. There is basic implementation. There is also implementation of deep learning in H2O, but it might not be as complex as TensorFlow, for example. And the second question was how we handle licenses in driverless AI. Driverless AI is closed source product. It's free for academia. So if you are a student or teacher, you can get it for free for unlimited time. You can get a free 3 weeks license to start to play with it, and then you need to talk to our sales team what we can do next for you. Did I answer your question?
Yeah. I mean, if you could give me a sense of the levels of licenses, on how many subscriptions?
We are really. This is always customer specific in H2O. We don't have like specific guidelines. We always try to make every customer happy as much as possible. So we don't have specific guidelines, specific steps for this process. It's really customer specific.
Yes, in driverless AI, when you're done with the model, is that like a black box that you can just take a face value, or if you actually got the results, can you go back and take a look at all the details and how many models were trained and the different results and the comparisons of the scores and stuff like that?
Mm-hmm. If I understand correctly, the question was if it's just the black box or if you can see the model details somehow. Yeah. Yeah. So it's not just black box. If you train the driverless AI model, you get this module artifact. It's just a fancy zip file which you can extract, and it will contain all the transformations what we did. So you can actually see in the YAML format what transformations we are executing, in which order, what data, what are the inputs, outputs, what are the types, and so on. So actually, when you train the model, it's all transparent for you. And when you finish the model, you can also use driverless AI to interpret the model, so you can actually see all the details how we reason about some specific rows.
All right, one more question.
Thank you. Wonderful presentation. I was just wondering, in the governed ML lifecycle slide, the part about model management. Is that handled in any way by Sparkling Water itself, or is that done kind of externally in Spark?
Yeah, thank you.
And one other thing, do you have any general best practices advice for model management?
Right now we are still working on it. This is just a prototype in H2O. I don't want to show anything yet. But this really depends on what you need. Model management can, for some people, it can mean just having a designated folder where they put their models. But this just doesn't scale at some point. For us, we are thinking of this having some specific database solution where you can run some meta search over the models. And the models should contain all the artifacts which you need to productionize the models, such as specific jar files for Java productionization, Python tools, Python libraries, everything. Basically, if somebody new comes to your company, we want them just quickly productionize this model. You don't have to install anything there and there and there. Everything should be at, okay, this model called A1, all the tools are here and the model is here. So that's how we think about it. It should be self-explainable. Right now, Spark itself doesn't do model management. It's a different question when it comes to Databricks. They are working on the MLflow, which is an amazing project. And they are trying to solve this task as well as what we are trying to do.
Okay, I lied. Final question.
Not a question, but a comment for the people in the room. We're going to have a tutorial right after lunch for 2 hours where we're going to be building a full end-to-end machine learning project that will go into 2 products from H2O to recreate it, almost as good as driverless AI. We're going to see one part where driverless AI would do better, and we would want to have that, as well as another prominent tool, their existential competitor as well. But we're going to build everything from beginning to end and operationalize it, and then go deeper into what it means to, say, automated machine learning and not needing data scientists anymore.
All right, thanks, Jakub.
Thank you.